Welcome to the world of business. The company behind me is a medium company by industry standards, and like many companies, it's owned by a larger company. Today, more than 1,400 people came to work here in a variety of careers involving in manufacturing, engineering, and marketing, just to name a few. Today, we're going to be looking at some of the careers needed by industry and some of what they involve. These may include areas that you know about and maybe some areas that you don't know much about. We'll follow the course of a product from its design through production through the eyes of some of the people involved in that process. We will start with a product as an idea given to an engineering project team to develop. Terry Landis is a senior mechanical engineer who helped develop the Model 3080.
As a senior mechanical engineer on the 80 series project, my involvement began with the definition and evaluation of the design concepts. These design concepts were generated and evaluated for their producibility. We settled on one concept that had all the features that would allow the development of a family of products around those features. Once we settled on a design concept, the detail design work begins. The mechanical detail design process begins with a layup. The layup is a scaled-up, accurate drawing that locates all the components into the package in the most efficient, producible manner. At this stage, the mechanical engineer interfaces with other mechanical engineers working on subsets of the instrument, such as the mechanisms, and other electrical engineers, installing the printed circuit boards and electrical components into the package. Once the layout is...
Because if you can't, I seriously suggest you start looking for another job.
Let us recap. Petramco is proceeding apace. A negotiated settlement is being explored in good faith in the Celia Robinson case. The Lewis tax audit is scheduled for the 19th.
18th.
I stand corrected. And Mr. Cifuentes' recently acquired Figueroa case should yield a primo wrongful death suit. Nelson Gallagher is one of the wealthiest real estate developers in California.
Many cases here took as long as 20 weeks, and the result of that tooling is a very detailed, inexpensive part with very accurate features and reproducible for many thousands and even millions of parts. One of the areas of design that I got involved with during the development of the optical sensor involved use with the laser and some reflective components. After the first instruments have been built and tested, the data is put into the computer and the engineer starts to analyze the data. He can then characterize the operating characteristics of the mechanism and input those characteristics to the software engineer for programming into the instrument.
A key element in the development of a new product is the PC boards, drawings, manuals, and graphics needed for the product. Linda White is a technical writer in the Technical Publications Group.
As a technical writer, I assist various departments in the company with their documentation needs. For example, I support the engineering department by helping them to document their design and development process. I proofread, format, and edit various engineering and test lab documents. I assist the technical support department with the preparation of service bulletins and field test procedures, which are sent out to the hospital technicians. I also write for the company newspaper. The major focus of the publications group, however, involves the coordinating, writing, and editing of the product directions for use and service manuals. I coordinate the different groups associated with providing information for these documents or for reviewing the document after it is complete. The groups include engineering, quality assurance, regulatory affairs, marketing, legal, printed circuit board design, drafting, technical support, and graphics. Since coordinating is important to the job, interpersonal skills and communication become an important part of the job too. As a technical writer, I gather information on a product either by interviewing the engineers developing that product or by revising and compiling various documents that already contain the information I need. I also receive rough input from engineering and technical support, which I rework into the necessary format. I handle the instrument myself when it is available to write the operating instructions from experience or to see if the displays are accurately described. Sometimes I have one of my coworkers try to operate the instrument based on my operating instructions. This is the best way to check my writing, especially if the other person has never seen the instrument before. It is important to know who my audience will be for a document, that is, who will be the primary persons making use of it. For a directions for use manual, this will be a nurse on a hospital floor, and for a service manual, it will be IVAC zone repair technicians or technicians employed by our customer hospitals.
While Technical Publications works on the words for the document, they draw on the product graphics group for labels, pictures, and other graphic needs of products. Sandy Knox is a graphic artist who works with other members of the product graphics group, developing the range of graphics needed for new products.
My name is Sandy Knox. I'll be taking you through our graphics department to show you how we help produce the product. When we create a directions for use manual, the order of steps would be receive text from technical writers, draw layouts, create illustrations, do typesetting, paste up, purchase. Using the text and sketches of desired illustrations, the designer does layouts for each page of the manual. Probably there would be an attempt to place an illustration opposite the reference to it. The components that go on each page are pieces of a puzzle that must be worked together. Usually several layouts are done to fully explore the possibilities. Normally, the layout that is easiest to understand is the one that's chosen. Next, we finalize how the illustrations will look. They are usually done oversized to make it easier to add detail. Here, Rod Rodolfo is working on an illustration for a manual. He worked with the development engineer to determine how to use the instrument in any hand position that may be called for. The illustration can be photographically reduced to the desired size when it is completed. We achieve the background color for the illustration by cutting a mask from opaque material called amberlith. It is placed over the illustration and cut exactly to the outline that is desired. As you can see, the material is somewhat transparent to the eye, but it will be black when photographed. This is the typesetter room. Kathy McNamara will show you how her file looks on the terminal and how that is composed on the preview monitor. Once she is happy with what she sees on the preview monitor, she will send it to the typesetter unit. The typesetter unit is a very high-speed dot matrix printer. It takes a total of about 15 seconds to print this file. When it's done, she will transfer the cartridge to the developer. At this point, Kathy can see her file in print. This is a finished paste-up. We create this black and white master that can be reproduced to the exact same dimensions. Normally, this master is kept on file here in our company, and copies only are sent out to vendors for manufacture of the pieces. The areas on the artwork that are black will receive ink. The areas that are white or clear will not receive ink. The ink can be any one color. It is with multiple overlays that artworks can be turned into multicolor pieces. We translate each label on a product when we intend to sell a product in a foreign country. This is the same label in 8 different languages. The graphic artist had to calculate the number of characters that would fit before ordering the typeset or creating the paste-up. The process starts when the designer working in their native language finishes the first language. Then, when the paste-up is finished and approved, it is translated into all the other languages. There are always minor adjustments to be made to fit different amounts of words into the same space. This drawing was not drawn by hand, but was created by Chris Collins with the help of a CAD/CAM computer system. Chris digitized the coordinates to build these figures and then made a paper copy with the plotter. We use these paper copies for visual reference by the engineering, documentation, and production groups.
Once a product has been designed and documented, it must be tested by a group outside development engineering to verify that it works the way it's supposed to. This is one portion of the job of quality assurance. George Robles is the quality assurance engineer responsible for evaluation of the Model 3080.
As a reliability engineer, one of my job functions is determining the probability of an electronic instrument to perform properly under specific conditions for a stated period of time. This is otherwise known as probability of failure. Reliability efforts begin at the design phase of an instrument and continues throughout development and production phase. During the design phase, there is a joint effort between research development engineers and the reliability engineer to review instrument specifications for consistency and completeness. These specifications will include information such as the hardware reliability requirement and useful life of the instrument. Using this information, the reliability engineer then develops a model for reliability prediction based on the actual parts used in the design. This analysis is a tool for finding weak points in the design and obtaining a relative indication of inherent reliability to compare to reliability goals. One of the tools used for this analysis is a computer simulation of circuit functions and calculations of the probability of failure. In addition, reliability testing is performed on the instrument. This is where the instrument is operating continuously under normal environmental conditions. From this, the reliability engineer can determine which areas of the instrument are prone to early failures.
The shift from development to production of a new product is a complex task. For example, as the cost of building a product continues to rise, automated means of assemblies are being more widely used. Applying technologies is the challenge to manufacturing engineer Ann Fitzgerald.
As an industrial engineer, I play several roles. I'm called upon to be a facilities planner, drawing office layouts and planning moves within the building. I act as an advisor to people who are having difficulty meeting production schedules. I am an efficiency specialist who's trained to look at a process and find a better way of doing the same job. On the production lines, we can save company time and money by making suggestions for improving work methods. We try and arrange workstations so the product is built in a logical sequence. We also go out and do time studies so that the workstations are balanced and each person working on the assembly line is doing about the same amount of work that the person next to him is doing. This provides for a logical sequence of events, and it causes the product to be flowing down the assembly lines a lot easier. An industrial engineer is also called in to do time studies on machines. Before a company commits to buying a machine, such as the wave solderer or the machines that stuff printed circuit boards, the industrial engineer comes in and determines exactly how much work can be produced by these machines as opposed to how much work could be done by hand. A cost justification is worked up from this information, and the industrial engineer is the one that does that. Without this cost justification, the company will not approve of a big purchase of this type of equipment.
Efficient manufacturing requires testing and verifying that the final products work properly. This testing is done at various stages of production, ranging from the parts coming in the door to the final instrument. Test engineer Jim Groves helped develop the testing strategies and fixturing for the Model 3080.
My job is to design and build up pieces of test equipment which will aid in the construction of IVAC products. When you take a number of components that work fine unto themselves and then merge them into a well-thought-out complex system, that system doesn't always work when you turn it on the first time. No matter how careful you've been, things can go wrong, components fail or are damaged accidentally, and parts can be misaligned. Anyway, the answer is testing. We look at many components as they come in the door. We test the PC boards after wave solder, and we test the sub-assemblies. Lastly, we test the completed instrument to ensure that we're sending a well-heeled product out the door. When a new project like the 80 series comes along, we sit down with members of the project development group and outline what test equipment will be needed. Then, later on, when the project is solidified to a good extent, we'll build up our equipment. Now, I begin with a few ideas of how a test fixture should operate, and then I scratch out a hardware design on paper. The next step is to draw the schematic on a computer. Depending on the complexity of the circuit, it can take a good deal of time to enter the schematic, but once the schematic is on the system, changes can be made very quickly, and it is very readable. I give the schematic to an assembler who builds the board up. Here's the same circuit again, built up on perforated fiberglass board. On the underside of the board, all the connections are made with wires wrapped around these small posts. We try to avoid permanent solder connections because changes are inevitable. On the top of the board, the components are in sockets, and the individual components are on removable headers. Next, the board is hooked up to a prototype system. I work out the hardware and software problems, then box it all up in an enclosure. Another type of test fixture is the board test system. It consists of a microcomputer, several rack mount units, and an interface to the board which operates partly by vacuum. These pins are gold-plated and spring-mounted and contact the board on the clad side. The top covers over, and you place the PC board on and start the system up. The computer runs through a series of tests written specifically for each board. Failed boards are sent to repair technicians and then run again. This is a final test station. A number of instruments can be tested at the same time. The operator enters commands at the terminal and is prompted by the CRT display. The station also has a printer attached for pass and fail messages. This way we have a short-term record of each instrument as it travels through the production and QC process.
It takes a variety of careers and jobs to efficiently produce and design a new product. What we've seen here today is just a brief overview of some of the careers that are needed within industry. If any of these careers seem interesting to you, talk to your guidance counselor. It's your future. Make it interesting.